Hey everyone, how's it going? Welcome to the stream. So, since 2 nights ago, I actually did a little bit of work yesterday, basically. And I thought I'd start off the stream by just sharing some of that work because I think it's interesting and useful. So, on Tuesday, we worked on, displaying pointers. That's it, pointers and references. So that's this change here. I think I didn't commit it on stream, or no, I did. I think I ended the stream by committing it. So that's basically all this stuff here. So since then, I decided to just take care of a couple of things that were sort of annoying me, like changes that were just sort of hanging out in my list of changes. So for one, the wait for debugger attach. So this was a feature I added recently, which allows me to basically start up Vectrex and have it wait for me to attach a debugger to it. That was great. However, it kept happening that I'd go in and like comment that line out, comment and put it back in, because sometimes I just wanted to launch it and not actually attach my debugger. What I did now is I just did a very small change. You can see it here. What I did was, let's see here. Yeah, so if a debugger is already present, well, we just attach. That's pretty much the same as before. Although, yeah, I suppose I just realized I didn't do the break on attach for that. Okay, I could fix that. But anyway, and basically, what I do is I have a message box that shows up and asks if you want to wait for the debugger to attach. So this allows you to skip it. So to show you what that means is, let's say I'm here and I hit F5 to start debugging. It'll launch this, and now it'll pop this dialog here, wait for debugger to attach. So if I say no, then I just am able to continue here. So that just basically allows me to skip that feature. What I really should do is have it like show a dialog and run a little thread that like looks to see if you're already attached and all that stuff. And once you are attached, close the dialog. I didn't do that, but you know what? That's fine. I don't feel like I don't need to invest too much time into that. So that's one change. Another one, this is just another random one. I had a change for a while. This vsync code that I had for my SDL engine, I had it commented out because I didn't want vsync on by default. So I decided to wrap it up in an option. So that's all this code here. Basically what that boils down to now is, I think I can launch it from here. Let's see here if this actually loads. Oh, it's just building. And hitting some breakpoints. Hold on a second. I think I just need to configure my build to launch. Whoops, not that. It's add debug configuration. That's what I wanted. I don't know why this keeps happening, but basically, if I can just get a path to my, hold on, Vectrex, let's say Vectrex Pong here. Just grab this. There we go. Okay, here we go. So up here you'll see the frame rate. It says about 300 FPS, 382, whatever. Now if I come in here, settings, I now have this display vsync, which I've put it on. We should hit about 60. See, 59, 57. So it's basically trying to keep, it basically enables adaptive sync. When I'm off stream, this actually is a solid 60, but you can see here that it sort of fluctuates, and this has something to do with the fact that I'm streaming at the same time, so there's some pressure on the GPU. But if I just disable streaming, vsync altogether, then it runs, you know, much higher frame rates. So this is as fast as we can go. So I found to disable vsync is better for my stream, but when I'm not streaming, at least on this crappy computer, vsync on makes it feel a bit smoother. Not a huge difference. But anyway, now I wrapped it up behind an option so it can be toggled in there rather than me having some code commented out, you know, just in carrying that through all the time. So that's done. The other minor change I made here was when I started working on DAP, you know, this debug adapter protocol, part of this making it work was using standard in and standard out, stood in, stood out stream for the communication from VS Code. And I think that's just basically it's part of the protocol, that the protocol just uses stood in, stood out. And as such, I couldn't use my typical, because you know, my emulator usually writes a whole bunch of information to stood out, but I couldn't do that anymore. So I did this like kind of hack that was like route all that stuff to a file. But the thing is that it would route to a file, but it wouldn't flush it. So I did a change here that has this kind of feature called auto flush stream that I enable now. And what it does is that every time I write, like I do a console or printf or errorf, whatever, it also automatically flushes the stream. So that means that, you know, while I'm doing my development here, I can actually take a look at that file. So it's like over here, print stream, and you know, it'll actually be updated on the fly because I'm actually flushing it out. Otherwise, what happens is it just sort of accumulates in a buffer, and typically because I never close the stream because I don't exit gracefully yet, I just lose that data. So now by at least flushing it, we'll see any import and output that we want to see for now. Ultimately, I'm not going to be doing this. Ultimately, I will instead, most likely, do this through a socket. And so what that means is have some kind of dummy program that sits next to my emulator. And basically what I'll do is that will, like VS Code, let's say, will speak to it through stood out and stood in. And then this little dummy program will translate those into and resend those over sockets. And then my emulator will connect to a socket. So this will allow me to completely decouple the two, continue to use stood out like I used to, and have a socket for the interaction with the debugger, the debug server, I suppose, or the debug client, I should say, since we are the server. And the other thing I did too with this change was just make the files output in the right directory. I have this data dev directory in which I put these kinds of files. So they were originally appearing in the root. Now they're appearing in here. So just some cleanup there. So they don't show up anymore in my commit here. Oh yeah, this was just accidental. Oh yeah, so this is a cool change that I did last night. So those of you who've been following me and watching me implement the parser for the stabs format, which I call the Rst parser because the file format is the file extension is .rst. If you've watched me, you've seen me basically use std regex for regular expressions, but it got complicated, and it got complicated pretty fast. Like it was difficult to read. You can see here on the left side, I had a whole bunch of these regex, these std regex objects with these complicated regular expressions with a bunch of capture groups, and I tried to help myself by saying what each capture group index referred to. So like here, 1 is address and 2 is label. Here, let me do that. And then I had some bigger ones here, like 1 is string, 2 is type, 3 is other, 4 is description, 5 is value. And of course, here it's okay, but then it's when you're trying to read the code, you're like, match of 1.string and match of 5.string. These don't really mean anything. So what I did is, maybe I'll show, instead of showing it here, I'll show it in the actual code editor. I think it'll be easier to see. Okay, and I'll just zoom in just a little bit. So what I decided to do was I created a base class called match base. which basically holds a regular expression, a match, and whether or not it has matched. The idea there is you construct it, so you're not supposed to use this directly, you're supposed to use a derived type. But I guess I suppose I could make all of it protected. But anyway, so what you do is a derived type will provide a regular expression string and will provide a string to match against. And then it'll actually immediately invoke the match and store whether or not it was matched. And then there's this implicit operator bool cast that tells you, that'll return true if it's matched or false if it hasn't. And then what I did is, for each regular expression, I now wrap it up in a little struct like this, a derived class. So here is my match a label line. This here now, this was the actual regular expression, so you can see it's been tucked in there. So label match derives from match base. It specifies this regex. The string that you pass into the constructor gets passed up. And then what I do is I effectively give names to the groups that I match. So, match of 1 is the address, and match of 2 is the label, as I wrote here, right? And I did the same for pretty much all the other types. You've got some more complicated types here. And I even was able to add some logic to it. Like here, the LSIM match, which was a bit more complicated, was matching either a type definition or a variable declaration. And so what I did is, you can ask, is this a type definition? And it looks at one of the match things. And if it is, you use this interface. Otherwise, you use this part of the interface. And there's actually some overlap in there, like type name and variable name are both stored in match of 1, but you don't really need to know that. You just say, give me the type name if you know you're dealing with a type, or variable name if you're dealing with a variable. So this basically abstracts the notion of the match that we're doing. And then in terms of usage, it looks kind of nice. It looks like this. So for example, that stab string match now looks like this. You go, if auto stabs equals, and then this is the part about doing the kind of bool thing. So this will do an assignment, and then it'll evaluate whether or not this is true or false. And if it's true, we'll enter into here. And now we've got this object called stabs in this case, on which we can query those matches like type and string. So that's pretty nice, right? And if we get into the more complicated ones, so here for the NLSIM, that's for variables and all that, we drop down here, and you see here I'm creating an L symbol match, right? So if this is true, now I do that thing of, is this a type def? And then I grab its fields. If it's not, it's a variable declaration. Oh, sorry, that's not the if not, it's over here. It's a variable declaration, so from there I grab the variable name or the variable type ref ID. So way more readable, easier to use or harder to misuse. And another advantage to all of this is which is what I was thinking about was, right now I'm using regex, which is kind of slow, but this would allow me to very easily replace the regular expression library I'm using. I just have to change these classes, which just change effectively this part, a couple of parameters, but everything that's public just remains the same, so the usage of these classes doesn't change. Which is pretty much the point of encapsulation, right? So I'm pretty happy with this. I just kept thinking about how like a lot of languages offer, like in Python and stuff, offer you the ability to give names, meaningful names to your groups, and then you look them up by name. But as far as I know, you can't really do that with this regular expression library. And even if you could, it would only make it slower, right? Having to do like a string lookup by name for each group, it just didn't seem great to me. So instead, I decided to just give them names as functions, and that's much faster. And it pretty much achieves the same thing with just a little bit of more typing for creating these types, which I don't find so bad. So you can actually see the differences if I pop up, let's say, beyond compare here. This is all the regex stuff, but I wanted to show more the differences in usage. So like here you can sort of see, it's a little bit hard to see, I guess. Is there not a way to zoom in a bit, this thing? I guess I have to change fonts or something. I was sure there was a... No? Control, scroll, alt, no. No zoom in. Well, hopefully you guys can see this, because I know it's a little bit small, but basically you can see here what was once a regex match here and all that turned into that simple auto label line. All of this just looks a lot cleaner to me. So here's a regex match for the stabs RE, and again, like I was showing, you know, grabbing out indices out of the match here. Easier to read now. In some cases, I don't really even need to put them into these local variables, but I didn't want to make too many changes at once, so maybe later I'd remove some of these. But yeah, pretty happy about this change. I think this is going to help me to do more changes in this file. And another thing I did is I moved all these constants up out of the Rst Parser and up into an anonymous namespace. So the actual code for the Rst Parser is a little bit simpler, because it's actually quite complex now, I find. I don't like how many levels of depth there is here, like how many levels of indentation. So this to me is usually a sign that it's not good. I should break this up into functions and stuff. So that's somewhere something I'll be doing eventually. But this helps a little bit, just kind of cleaning up all this code. And yeah, so that's it. So that's basically where we're at. And yeah, and just to kind of show again what it is that we got done last time. So if I hit F5, we were working on pointers and references here. So I won't attach my debugger here. So here you can see I have a variable int a. It has the value 4, and then I start creating pointers. Here's a pointer to a, and what we display right now is just the address that the pointer points to, and this here happens to be the address of stack variable a. So it's at cbdf, right? And then we write through the pointer, and we basically change a to 5. This creates a second pointer that is assigned to p, which of course ends up with of course the same address. We write through it and write 6, that changes a. Here we have a reference to a. A reference is basically treated like a pointer, so we can see that it refers to the same address. And through it we write the value 8. And then we have another one here, does the same thing. And then we have a pointer to pointer, which here shows you that it's getting the address of the pointer p, which on the stack is actually 2 bytes before variable a, which makes sense because the stack grows in the negative direction. So it gets, you know, the value gets smaller and smaller. So here, because it's a pointer, it's going to be 2 bytes before variable a on the stack, and then we write through it and we change this to 12. So that's basically what we got done last stream. What I would like to do now is actually, you know, have our pointers display proper values. So that's what I'm going to work on tonight. Okay, that was a lot of talking. Take a sip. Okay, let me bring this back down to my 100%. So let's get back to our debugger here. We were working in the variables handler here. Now obviously this has gotten rather large. This is where we handle, presently we handle the two types, basically, the primitive types, and the one we added last time, which I called an indirect type for pointers and references. And as I said here, to do, read and display value at value address. So that's right. And the thing is that what I'm reading may itself be a pointer, right? An indirect type, in which case we want to keep going. So there's a little bit of work I'm going to have to do here. So let me start thinking about how I'm going to split this up. So I know one thing I'm going to have to do is, in order to expand, we're going to want to let me do this here. So let's say I move this into this part there, and then similarly do that here. What I will need to do, I mean, I'm not sure that this is just temporary, but I just wanted to see here. One of the things that DAppVar has is something called a variables reference as well. And basically what it says is if variable references is greater than 0, so if it has an identifier, the variable is structured and its children can be retrieved by passing variables reference to the variables request. So we actually use this already, but right now it's assumed, let's see if I can find it, it's up here somewhere. The variables reference is, here it is. When we receive this request, we assume that it's a call stack index. But that's fine for when it is a call stack index, in which case we want to do this code here that grabs all the variables for a given scope that's related to the call stack frame. So that's all the code we have right now. But we also want to be able, we're also going to receive like calls for this for expanding variables. So I'm going to need to be able to differentiate the type of variables reference that I'm holding, so that I can have one that says this is a call stack index, and another one that will say this is a indirect, I don't know, I'm not quite sure what to call it yet. I got to think a little bit about how I'm going to store this information. But it would be, I suppose it would be an indirect type. And I also got to think, okay, so say I have that, what am I expanding it to? Do I create a variable that wraps this thing? Like, how do I display this? Because right now I don't have, my indirect type here is just a type. I don't actually have a variable for it. Let me see here. Yeah, see, because on functions I have variables. But here I'm going to have to create one on the fly. I think that's what it means. Yeah, I'm just wondering, what should I do here? I'm going through some thoughts in my head of whether or not I want to create variables that are considered as part of the same scope. Because normally a scope has itself a vector of variables, that's true. But here, my variable is contained in the scope is a pointer, let's say. Now that pointer can be pointing to anything. So I think I need to, create some kind of, I think I'm going to have to create some kind of thing on the side here. Plus it stores a stack offset, so that's kind of interesting. Because it may not be a stack offset. Because this variable here, I'm saying stack offset, but that makes sense for a local variable. So maybe this is more of a local variable thing. I may have to distinguish those two actually, now that I think about it. scopes are made up of local variables, but maybe here I just want some kind of more generic variable, and the generic variable has a fixed address. That's true. Does that make sense? So then, let's say we want to expand. We say, okay, we've got an indirect type. For this indirect type, I need to add a sub-variable, a variable reference. And then what would that reference be? Obviously, it has to be some kind of sequential index. And the other problem I have is this will just keep growing and growing, right? Maybe it should be referred, like the ownership should be part of this variable here, the scoped variable, that is. So this pointer that we have, yeah, I can't do that though. Not sure. Really not sure how to tackle this. Because one thing is that, you know, the specific instance I'm going to have is going to be specifically pointing to an address that is in the function right now, but the next time the function gets called, that value may change, right? Which is why we compute an address here. But we want to be able to display a variable here, like let's say the dereferenced variable. Just thinking about lifetimes. How should I manage the lifetime of this thing? Alternatively, so like another thing is I could just skip the expansion, but the thing is I'm going to have to do expansion anyway for a whole bunch of types, like for arrays and stuff like that. So I am going to have this problem no matter what. So what should I do here? Not sure. I suppose what I would need to do to make this, okay, if I think more of like in terms of a functional approach to this, right? I would need to be able to know which indirect type this new variable reference is a child of. And I suppose I don't really get that information because we're just giving it an ID. Like it says the variable is structured and its children can be retrieved by passing variable references to the variable request. Sure. But when we are when we do that, we don't know what, like we don't know what our parent type is. So that's sort of what I need to be able to deduce here. I suppose I could, if I knew that I was derived from a stack variable, but then again, what if I have to double expand there? That's not going to help me much. So part of me is thinking I would need to store some information somewhere, but every time I got to deal with that, then I got to deal with lifetimes. You know, when we're finished with this function, how do I know it's time to clear those? I don't know that here. I mean, I suppose I could track the scope that we're displaying, and I don't know. I don't really like it. I would really need a functional approach here, a way to, like, for example, you know, come back to this. So this is what I'm talking about. I've got this P here, right? So here I'm showing the address, but ideally you would see a little plus here that if you clicked on it, it would expand and then display the value 4, you know? So it'll dereference this and show us, oh, look, you know, this is an integer. Like this here is a int star. I think it'll show here int star. And the derived, like the child of this child variable will be of type int and has value 4. It won't say A. It doesn't care about that, right? It's just a pointer that happens to have the same address as A. But yeah, that's what our debugger should do. The thing is this child, like so far, all of these here map to a known local variable that I've stored statically that is made up as, like, it's part of the scope of this function. So all of that is, like, you know, baked, and I don't create anything on the fly. But for these kinds of variables, I need to create them on the fly. And the thing is, if I create them on the fly, then there's this problem of ownership. I don't want them hanging out just all the time, but at which point do they stop existing? And so I suppose, you know, logically it would have something to do with the scope or with the presence of this parent here. Hey, what's up, C Decompilador? How you doing? Listening to me struggle over here? Yep, I am implementing a debugger. It's basically, it's actually a debug adapter that I'm writing. It's this, I don't know if you've heard about debug adapter protocol. It's what VS Code uses, and a bunch of other editors, Visual Studio, Vim, Emacs. They all support this adapter protocol, so that it allows you to connect these different text editors to be able to debug. You know, let's say there's a debug adapter for Python. Then all these editors, if they implement the debug adapter protocol, they can all debug Python through it. So, like, the hard work of, let's say, the debug part is in the adapter, and then the IDEs have the work of talking to it and then, you know, doing the display part, but they don't have to actually write the protocol for debugging or figure out how to talk to Python and all that. That's abstracted away. And what's cool about it is that, you know, if you wrote support in your editor for a debug adapter protocol, you can debug multiple languages as long as there's an adapter for it. But you can use your debugger in CLI. I do have a debugger in CLI. Oh, you're saying if you use the debug adapter protocol? Sure. If there is, you know, if someone wrote a CLI debugger that speaks debug adapter, like speaks DAP, then yeah, totally. This is just a shell, right? I happen to be using VS Code here, but, you know, I know Vim supports it and Emacs. I know that Visual Studio and Visual Studio Code, and there's a few others. But yeah, sure, if someone wrote a text debugger that speaks debug adapter protocol, then that would work as well. Yes, that's right. I do actually upload pretty much every episode, every stream I've done. And what, I'm at 120 today or something. But yeah, they're all on YouTube, and they're, you know, they cover me basically starting off very, very early writing this Vectrex emulator. And this is the same thing. It's the Vectrex emulator, but now I'm writing a debug adapter protocol in it so that if you compile a Vectrex program in C or C++, using this GCC fork, it'll generate this debug info in stabs format. I parse it and speak debug adapter here so that you can debug these C++ programs. Yep, modern C++. It's basically C++ 17. And once it gets to 20, I'll change my title and it'll say 20 up here somewhere. This is kind of like my excuse to use the latest C++, because at work, you know, you're rarely ever allowed to use the latest version. Like for instance, where I work, I'm presently stuck at 14, and that's a pretty recent thing. We were on 11 up until like a couple months ago. But at home, I can use whatever I want, right? So this is where I get to play with the latest version of the language. So one thought I had is, in terms of lifetime, one thing that happens here is whenever this function gets called, it's pretty much always going to start from a call stack request, right? So we're going to get one, and we're going to know a current function that we are, we are in some function at all times. And that's, but if you click on the call stack and all that. And then when you click on a function, that becomes the current function, and then we display all its local variables. And what I'm thinking is that these indirects are part of that. Here we are, right? So maybe what I can do is I can hold in my debugger dynamic created variables that are bound to the current function. And what would happen is that whenever the function changes, I can, so let's say we go into another function, or you click somewhere else in the call stack, the returned function here would change. And when that happens, I could clear the variables that I have so far. So that's one option. So some of the things added to C++20 are just focused to library writers, but modules and coroutines look great. Absolutely. You're right about that. It's true that a lot of the features in 20 are mostly for library authors. 17 had a lot of these features for everyday programmers, like variant and optional, any, those kinds of things. But I think there's a lot of stuff coming in 20 that'll make programming easier in general. One thing I look forward to seeing in 20 is, what's it called? Contracts, is it? No, not contracts. It's the other one. I always mix those up because they both start with C. There's contracts, and there's the thing there where, like, you can say, like, this, you're talking about a template, and you say this template parameter is of this type of, oh man, what the hell? I can't remember. Concepts, exactly. Thank you. See, contract and concepts, I always get those two confused. Not to mention const expert and const eval. That const eval is new, right? Lots of con things. But yeah, concepts. Concepts looks cool. I think it's cool because we'll end up with, less, crazy 1,000 line error messages when you make a mistake with a template. I'd rather see something like, this type doesn't match this concept. It's gonna be nice, and it'll say why. Right, const eval. Yeah, so you'll be able to in C++20 also say things like, here's a version of my function that can only be called at compile time. So you know how like const expert can produce a function for both compile time and runtime, but sometimes you only want it to pick that one for compile time and another one for runtime. You'll be able to do that in 20. That actually would help me in this code base. I have an example of a function that is fine for compile time, but is no good for runtime. Although I might be able to make the two the same, because in 20, another really cool feature is that there is const expert new and const expert delete. So that means you can actually do in effect heap allocations at compile time. So that means you could have a const expert std map, std vector, and that would definitely help, because some of the stuff I have here that I want to do at compile time, I'm forced to do like recursive lookup for stuff that I would normally want to use a map for. So I'm doing like linear lookup, you know what I mean? So there's a bunch of stuff that's coming that's really, really nice for compile time programming. Very helpful for emulators, because so much information in emulators is statically known, right? There's a whole bunch of stuff that we know about, like the CPU and the layout of memory. And if you can generate most of the code at compile time, you can produce really optimal code. So that's some pretty cool stuff that's coming. So yeah, maybe what I was thinking here is that's it. So if I sort of store a set of, let's say, dynamically created variables for the current function that we are, or the last function that we inspected, then maybe that's where I could store this information. Yeah, so let's try that. I'm gonna give that a try. I'm gonna go down that route. But in order to do that, let me undo some of this, because I think now that I know I'm gonna do that, I'm gonna have to change up a little bit, like that. I'm gonna have to change my types a bit. So what I call a variable here, I'm gonna have to call it a local variable, or at least create a derived type called a local variable. Because what makes it local is a stack offset. And then this will be as opposed to a, I'm not sure what I would call it. On the other hand, if I know that I'm adding it as part of this function, I can keep, no, I can't, because the pointer could be pointing to anything. So maybe an absolute variable. I don't want to call it global, because that's not right. I mean, alternatively, what I could do is I could have it so that variable stores either or, you know, it's either a offset or a variable, and not make difference in the name of the type. So maybe I'll do that. Let's see how that works out. But I won't easily be able to tell which one it is without like a bool or something. I suppose I could create a type for each. I'm thinking about how what I really need here is I forget what you call it, but basically a type that is I guess I need a strong type. You know, something along the lines of like, I'm just trying this here because like, I'm thinking like it would be interesting to do something like this and then have like a using stack offset equals to strong type of UN16T, let's say. So we call this a location. So location is either a stack offset or an absolute address. And of course, I want to be able to initialize this guy. So we'll say T I'm going to have to give it defaults because if I add a constructor, oh, actually I think it's okay. So let's say I have this. Then when I create my variable in my Rst Parser now, let's see what this looks like. So let's say v.location will be equal to variable.stackOffset, and I can just create one here, like this. Does that work? I still don't understand the usage of std move. Have you read a bit about it? It's a very powerful concept. If not confusing though, if you really want, I don't mind explaining it. Would you like me to give it a shot? All right, I'll give it a shot. Because there's sort of like two parts to std move. There's like the part that, going to a bit what you wrote before, there's the part about std move, which is mostly, I'd say, for library writers. And that's the part that I think trips up a lot of people when you start reading about basically R value references, right? Everything to do with R value references is the part that sort of gets complicated. That basically when you have a type, or let's say you have a class. Let me write that over here. Let's say you're writing a class foo. If you know C++, then you can write constructors, and you can write destructors, right? You also know that you have like the copy constructor, which looks like this. And let's say you implement it. You have also copy assignment, which is pretty much the same thing, right? Returns a foo ref, and you go operator assignment, const foo, and like this basically is effectively the same thing as this, except for assignment. But then in C++ 11, they added two new ones, right? So we call these copy constructor and copy assignment. And now we have move constructor and move assignment. And that looks like this. Not const, two refs, we go like this. So that's the move copy, the move constructor. And then we have the move assignment operator. Something like that, right? So it looks almost the same thing. The only difference between these and these are that we add this extra and, this extra ampersand. So this you might have seen already, and we call these these are called R value references. And the whole thing about move has to do with this notion of R values versus L values. Right? So the name R here has to do with right side, whereas L has to do with left side. And what they mean here is like right side of assignment, typically, okay? And this is like the left side of assignment. And another way to think about that is left side is easy, right? We tend to think of this as a named variable. Whereas on the right side, we say this is an unnamed variable. It's also known as a temporary, right? So what I mean by that is, let's say you have some function. If I do int a is an L value, right? Why? Because it has a name. This is an integer that has a name. On the other hand, if I say a is equal to 5, 5 is an R value, because 5 is on the right side. All right, well that's not super interesting, but if I did something like a function that returns an integer, like get integer, and this this returns some integer like this, and I do that, then this is an expression that returns an R value. This 5 here, when it gets returned, it has no name. It's just this expression evaluates at runtime into something, and this something is an integer that has no name, and it's a temporary, and it'll go into here. Now, it's not super interesting working with integers, but if you're working with a class, let's say foo here, if I say get foo instead, and let's say, foo had some kind of, we'll just return a default constructed foo, like this. For some reason it doesn't like it. I think, it's because these are not public. So now here we're actually constructing a foo that has no name. We're not assigning it to anything. And then we're returning it, and it gets returned by value. So again, it has no name, you know. And then we're going to assign it like that. So here, what is returned is an R value. So far, so good? That makes sense? The difference between L values and R values? Another place where they show up is when you call functions. So let's say there's a function that accepts a foo, right? So let's say we have a, I'm running out of names here. I don't know, cool. And cool accepts a foo. So if I call cool here with A, I'm calling it with an L value. Right? On the other hand, if I call it like this, calling with an R value as input. So there's a difference here, right? This here is an R value. It's a temporary. We create it, and it has no name, and it's going to come into here. Now, of course, as soon as it goes into here, this gives it a name. It gets copied into this F, and an F is an L value. But this one here is an R value. And in fact, its lifetime is no longer than this expression here, this statement, right? As soon as you could think of it as once the semicolon is done, over here, that temporary doesn't exist anymore, right? Okay, so what about moves? So what's moves all about? So move is this idea of taking an L value and turning it into an R value. Move takes an L value. So in fact, I'll say stood move. So there's two concepts. There's the concept of moving, and then there's the function stood move. So stood move takes an L value and turns it into an R value. In fact, it's a cast. It basically just casts an L value to an R value. So it's a bit of a misnomer, because we say move. What we mean here when we say stood move is we would like to move this thing, but in fact what it does is it doesn't move, it casts. Very much like static cast or reinterpret cast. If you look at the implementation of move, you'll see that it's actually doing a cast. So what's the point? So the point has to do with heap, like it has to do with making things more efficient, okay? And mainly what has to do is with heap allocations. So let's say like my foo here made some kind of like expensive heap allocation, right? So let's say foo stores some integer buffer pointer, okay? So initially it's null, but let's say like, I don't know, in our constructor, we always allocate some, massive buffer like that. And then we use this buffer and all that stuff, right? So obviously if that's the case, then in our copy constructor, we're gonna wanna make sure to create a copy of that buffer as we typically do. So we'll do something like, buffer is equal to new int, well right now it's a fixed size there, so let's say like that, and then we'll do like copy into this buffer from the RHS.buffer, blah blah blah, right? Yeah, exactly. I think you're getting it. So I'll just complete this. So basically, just think like, let's just say that copy constructor does what you expect. It copies, right? So this means that if you were to, call cool foo here, what's going to happen here is, well, let's talk about the, whoops. Here, okay, sorry. So here, we created a foo. So this goes ahead and creates a foo and allocates one, possibly copies it on return, right? Because this is a by value. Although most compilers will elide the copy anyway, because it'll do what's called a return value optimization. But let's just say it didn't do that. First, you're constructing a foo, so that's going to do this big allocation. Then you're returning it by value, which could do a copy of that allocation. And of course, we need to make sure to delete here, right? So what's going to happen is we constructed a big buffer. On our way out from the get foo call, we create a copy of that value that we created here. So then it creates a full copy, copies all the values. Then the one that was created here gets destructed, so it calls a delete. So that's another heap thing, another go to the system and asks it to delete. And then it gets assigned to A, which is potentially another copy, right? So it's going to do another copy, and then the one that got returned will get destructed. So this is like, in the worst case scenario, a compiler that sucks at optimizing. For this one simple call, you could end up with up to 3 allocations and 2 deletions. Now, in reality, most compilers are smart, even pre-C++ 11, and this will just end up being 1 allocation. But because it wasn't guaranteed, we rarely would ever do something like this in C++, like pre-C++ 11. This is just not a good way to do things, right? If you knew that you were going to create something expensive, you typically wouldn't return it by value because you just didn't know. Maybe the compiler sucks, and it's a Tuesday, and the phase of the moon is different, and this time it decided not to generate optimal code, and you end up with this expensive copy. Think like std vector. Would you ever see code like this? This prototype, very rare would you ever see something like this in pre-C++ 11. And the reason was that this could be a very expensive value to return. So typically what we would see is something like get values, and then you'd say, hey, pass me in some reference or a pointer, to the values, and I'm going to take it and I'm going to populate it. So you allocate it on your stack or whatever, and you give it to me and I'll populate it. So, this is like C++ 03 and C++ 11. Okay? And it's all because of move. So coming back to what we were saying here is that what you can do with an R value is you can say, so this is that I'm going to ignore the assignments, because assignments are pretty much the same thing as, this is basically the same as that, and this is going to be the same as this. The only difference is you just have to make sure that since you already exist, you got to clean yourself up before you assign to yourself, but whatever, that's a detail. So here you can do something like this, right? You can say, I don't actually need to allocate myself. I'm just going to steal the buffer from the right-hand side, because the right-hand side is a temporary. Since it's an R value, it's a temporary. We don't care about it. Its lifetime is about to end. That's what an R value means, right? It's something that after this call it doesn't exist. You know what I mean? So what we can do is we can just steal its guts. So we can say, we can do this. And of course, we need to make sure that it doesn't delete itself. So this delete here of the right-hand side does nothing. So this is what a move constructor looks like, right? It's basically very, very simple. It's saying my buffer is going to just be the buffer of the temporary. And now the temporary's buffer is null, so that when it deletes, it does nothing. So you can think of this as very, very little overhead. It's a super fast copy. That's another way to think about it, right? A very optimal copy. And so if we come back here, now we did all this, right? But this call here will not take advantage of this R value constructor. This one here will, but this one doesn't really matter because it's already an R value. But this one doesn't. So what you can do is, as a programmer, you're like, okay, I want to pass A in, and after this call, I don't want ownership of A anyway. I don't want to use A anymore. So I know A is an expensive object. I'd like to move it into cool so that the value that cool sees is this exact same one that I created here, and it's not a copy. It's actually, I'm moving it in. So you'll do like this. So when you do this, you're casting what was once an L value of type foo to an R value of type, so you can think of it as foo, and then it becomes a foo ref ref. And so by doing that, all of a sudden, what's going to happen is, since now the type has changed to a foo ref ref, right, to an R value, it's going to want to construct the foo here with the move constructor. And so then it takes this A as though it were a temporary. And then it's going to steal its guts, clear it, and then this A still exists, right? That's the one trick here. that unlike a temporary that only lasts as long as the call here, after this, A still exists, you know? But this A is now an object that you should not use in the normal way, because we've moved out of it, right? We've moved it. So you know, what you're supposed to do, I think like the language basically says that by default, if you move, then this object, the only thing you can do with it is assign to it again. You shouldn't do anything else with it by default. You know, so it has to support being assigned to again. So you can, you know, create another foo if you want, right? Or call get foo again or whatever. You can do this. That's okay. But let's say, you know, foo has like, you know, members and stuff like that. Those may not be safe to call. Now, you can decide as part of your own type to say, here are functions that are safe to call on a moved from type. So I know, for example, like std vector, it's okay to call size on it. So if you move out from a std vector, size will return 0. This is well defined. But calling almost anything else would be undefined. So from the point of view of a programmer, right, there's library writers who will worry about how to implement these things here. But like 90-something% of programmers, let's say 99% of programmers who don't write libraries, you almost never need to ever write this kind of code. You know, most programmers, the only thing you really need to know is if you're dealing with a type that does heap allocations, right, that's expensive, you can use std move to move its memory around so that, you know, it's more efficient. And so like, let's say, you know, for day to day, you'll never, like, I'm showing you this stuff here. I don't think I've actually written a proper R value constructor and like a move constructor and move assignment operator. You know, I know how to do it, but I haven't had to do it because I just use the types that are available to me from the standard, right? So I use std vector and std map and, you know, std unique pointer. So that's a whole other thing, right? Like now you sort of get the basic premise of R values and move. Then there's these things called move only types, which are super interesting. Move only types are basically types that disable, like delete the copy stuff. So these are deleted. They actually set equals delete. And so you can't copy them, but you can move them because these are available. And so those, for example, unique pointer is such a thing, you know? Exactly. So unique pointer is a move only type by definition. So the whole idea behind unique pointer is unique ownership, right? So that's why it's done that way, so that, you know, you allocate a piece of memory and you store it into a unique pointer, and then there's only ever one unique pointer that can point to it, because if you try to copy it, it'll fail to compile. And it'll fail to compile because it'll say, hey, there's no copy constructor or copy assignment operator. So if you want to, you know, assign it to something else, you have to use std move. And what that does is it'll move the thing that's being owned by one unique pointer, the memory, into the other one. Exactly right. So that's all about transfer of ownership. Another interesting move-only type is std mutex. So, you know, a mutex is a operating system resource. It's not something you can copy, right? If you think about it, a lot of these sort of threading primitives are some kind of operating system resource for which there's only one of them that you construct, and there's no real normal concepts of moving them, but of copying them. But you can move them. If you would like to create a mutex in a function and then return it so that you can, you know, assign it somewhere else, you can do so by moving. So it's kind of interesting, right? You could think of it like, another good example is files. So if I create like a file stream, does it make sense to copy a file stream? You know, if I open a file stream to some text file on my drive through which I can write, you know, values to, but I'd like to move that. Like I'd like to take that file stream and pass it to a function so it can take ownership of it. copying it wouldn't really make sense, right? What two copies of the same file stream mean? Do they both allow you to write to the same file? But you can move it, so you could have only one owner. So anytime you have this concept of unique ownership, it makes sense to make it a move only type and to use std move to move it around. So hopefully I've clarified a little bit what move and R-value references are. Obviously, I'd point you at a lot of reading material. I know one thing, I can point you at something that really helped me. Although it was mostly about what was called, so do you know Scott Myers, famous guy who like wrote good books about C++? So Scott Myers has an excellent book on C++ 14. So yeah, it's called, where is it again? Is it Effective Modern C++? Yeah, it is called Effective Modern C++. I don't know why, here it is. So this book here. So Effective Modern C++ is a book for C++ programmers, and it teaches you like all the kind of advanced things from 11 and 14 that you should know about, and it talks a lot about move and all that. So this I can recommend. And in fact, Scott Myers wrote this article a while ago where he talks about what he calls universal references. And this article that he writes here, it's not specifically about just move and R values, although he covers it. But it's also about another kind of thing in C++ 11 called, we call them forwarding references now. And they are also related to R-value references and can be extremely confusing if you don't know the difference. So this is also some reading I could point you at. Cool. All right. So let me see if I can get back to what I was supposed to be doing. Although I really am happy to explain this stuff. So thanks for asking about it. All right, so all this, I think. Yeah. No, don't apologize, man. It's all good. It's all good. And I know it's confusing, so it's makes me happy to try to explain it. And then sometimes when I explain it, I realize there's gaps in my own knowledge and things I got to look up, or people correct me. So that's how you learn, right? They say the best way to learn something is to try and teach it, or to teach it anyway. Okay, so what's the problem here? It doesn't like, it's saying I can't assign to my variant that accepts either a stack offset or an absolute address. Why not? I don't understand. I guess because it doesn't, it's no, this should work, right? Oh wait, these are exactly the same type. This is not what I wanted to do. How do you do this again? Oh yeah, this guy gave a nice idea for it. I called them named type. Oh, that's interesting. Right, so that's it. I need something, I need a phantom type, as he calls it here. Something to distinguish them. So they're both of the same type, but I need to distinguish them. You know, this T, it's like you can see here, they're both strong type of UN16T, so it doesn't know which one you mean. Or which one I mean, I should say. So here, I guess you just create dummies for that. Let's see. He calls it parameter. Is there a better way to do it? Yeah, this is a really nice blog. This guy is a really good C++ programmer. He writes a lot of really interesting posts. Can also recommend this one. Hey, thanks for the follow, Shaka Shark. Appreciate it. And thank you for the follow, CD compiler. CD compilador. Sounds kind of Spanish. Is it a Spanish name? Are you from Spain or from South America or something? Cool, cool. My family is originates from Italy. I'm actually Canadian, born here, but my dad was born in Italy. So that's my last name. But yeah, it's cool. So here I see that he can do this thing here, struct meter parameters. Can I do that? Can I just write struct like this? Let me see, what is he doing here? So he creates a width parameter and can be declared within the using statement, making it possible. That's cool. That's actually what I wanted to do there. So it's just really a dummy type. So let's say like struct does that work? Looks like it. So this creates two types that are unique. I remember reading this a while back and thinking, yeah, this is useful. But now I actually have a use case where it comes in handy, specifically with using std variant. Oh, right, okay. Okay, so he didn't do the operator like I did. I kind of like it though. But he did do two different constructors. Could just use std forward though. Something like this is where universal references come in, by the way, or forwarding references. But if you do this, can you construct a default one? Probably. The default constructor variable cannot be referenced. It has been deleted. So I think I actually made it delete. So maybe that's why I can't do this. attempting to reference a deleted function. So it doesn't like this, what I did here. Why does it consider it deleted? Maybe if I do this. Add a default one and then add a forwarding one that takes a value. Okay, that looks like this part worked. That's interesting. So let's say we do it this way. Now, where we actually access offset here, we have to do location, and I'm going to have to get it as an offset. So that's a little bit annoying, to be honest. That's one thing I'm not a huge fan of, is like this whole std get thing, or get as. I love variant, but I don't love the interface to it. So I think it's like this, and then I would have to say like that. It's sort of like a cast. We're saying get this thing as a stack offset. So here I expect it to be a stack offset. So this, this has to work. There's get if, which returns a pointer. And if it's not a stack offset, this is actually going to throw or assert if you disabled exceptions. So did I get this right? Something still not compile. Oh no, okay, it's compiling. It's just because I still am running this last version of it. So let's build again. All right, so it's not bad. Okay, so what this allows me to do is, now that I can do this, I need to think about how I'm going to do identifiers. So I said function, variable, right. So I need this variable reference type to indicate that we're dealing with a call stack index. Just trying to think what's the simplest way for me to do that. Let me try something. Could I do something like yeah, so I'm thinking maybe something along the types of like variable reference type. I'll say variable ref type or something. Just keep it a little bit shorter. And let's say it's we call this a call stack index. And then the other one would be I don't know what to call it, expanded variable or child variable. So let's say we had that. Then could I define a type? Okay, and let's say we make sure that this is no larger than a uint8t. Then I could say or I guess I could say int type, which is 8 bits, and int value, which is 24. I mean, actually it should be 24, or I guess I should say size of int. Or maybe I should make it, because, oh wait, hold on. Depends on the variable reference type here. It's an integer. So that stores an int, yeah. It's okay, so we'll go with int. So that's size of int in bytes divided by 8. I don't know if I could do this. This has to be some kind of const expert thing, doesn't it? So I'm gonna have to do, okay, let's just say 24 for now. Probably don't need, in fact, I should make it the smallest possible because I don't want to run out of IDs, so even on a 64-bit platform. So let's say we did that. Okay, so then the idea there is that rather than casting this into a size t, we would cast it to a variable ref. And we would store it as a variable ref. Let's see if that would work. So basically what I'm doing is I'm defining effectively an integer in a variable ref here. This has to fit in an integer, right? In fact, I think what I'm going to do is type and value, and then I want to make a union so that I can just grab it as a whole and store it as an integer. Maybe I'll call this ID. Value type ID. Let's see. And we want a static cast that its size is less than or equal to integer. Sorry, size of integer, of course. All right, so say we got this. Now, where are we storing that variable reference again for our scope? It's here. There it is. So you see here how we're storing a variable reference here. So instead, we can say I think I can actually give constructors now to these guys. Type and int ID. I'm going to have to cast this guy. You know what? Let's do this. Let's move it inside. Let's call this type. Okay, so then we go variable ref of and take this as a value. Does that work? I think so. So what I've done is I've constructed a variable reference with the type that we want and its values. So then this is going to store the type into these 8 bits here. In fact, it's like more bits than I really need. I suppose I could even just make it like, 2 bits for now and make this even larger. But whatever, I don't care. 24 bits is much more than I need, I think, for now. And I should probably assert that the ID fits in there. Anyways, the point is we create a variable ref with this type and this value. The dot value here is to basically get it as an integer. It's so cool that you can add functionalities to unions like this. But I'm not sure there's actually much point to having it be a full union. Let me try something else. Let's do this. Let's do that, and then just have some kind of cast. I think I prefer that. Okay, so we do this, and then later where we grab the variables reference here, now we actually need to know what we're dealing with. Is it a call stack index or not? Because when we get called and it's not a call stack index, we're going to want to treat it differently when it's a child variable, let's say. So here what we're going to do is we're going to say variable ref now here we're going to say construct it maybe from int, or we'll just create a constructor that accepts an integer. So what's wrong here? Oh, right. I need to do int star of this and then dereference it here. So I'm using memcopy because actually that's what I'm supposed to do. I should actually technically use memcopy here as well. Does this work? What's the problem? Whoops. Okay, it's a pointer. And copy to this. And then here what we'll do is we'll say, result. Copy to result from this, size of result. There is one thing here that on a 64-bit platform we would want to copy into the proper part of the integer. So this might not work. So probably we do need to add some padding here to make sure everything is kosher. Oh, actually, integers are 32-bit, not 64. So this static assert will make sure that it does the right thing. So if there's ever a platform where it's not 32, this will fail. And we're using memcopy because that's the right thing. This memcopy actually will be optimized into just a reinterpret cast like I was doing, but this is technically standards compliant. We're not supposed to use reinterpret cast for this kind of thing, as it turns out. Okay, so then coming back here, we grab our variable reference like this. We actually construct it from this integer. Now this is a DAP integer. I might have to do something to get its value. Like I might have to cast it explicitly. I don't know if it'll do an implicit cast. Maybe it will. Let's see. Let's see what the compiler says. So if we have our variable ref like that, then here we can say, if variable ref dot type is equal to variable ref type call stack index. So if it is a call stack index, then we want to do all this code here. Oh, right. And of course the type. So maybe I won't do enum class so that I can actually compare it. Will that be okay? Yeah. So by not making it an enum class, then I can actually use yeah, the only thing I like about enum class is that it forces you to type out the scope. But the one thing I don't like about it is that you have to keep casting, which is not amazing. On the other hand, okay, you know what I'm going to do? I am going to keep, I'm going to make these private. Okay. So now I tucked away the cast internally. I think this should be okay. What's the problem here? Right. Is that problem of wanting to have the same function name as the type name. Can I do this? looks like I can. Yep. Okay, so coming back here, so if our variable ref is a call stack index, then we do all the stuff that we're doing in here. Obviously, this needs to be cleaned up because it's kind of gross. Why is it? No, doesn't like this. Yeah, it's getting totally confused by the fact that I have type everywhere. Guess I have no choice. Do the ugly getter thing. The reason I run into this is because I use the unfortunate convention of naming my functions with capital letters. I would love to go back on that, but I've already committed to this too long ago. It's an old standard that I kind of got used to. Coming from the games industry, it's something we do a lot in games, and now I regret it because I can see that if you name your types with capitals and you want to name your functions with capitals, you end up in this specific situation over and over where your getters can't have the same name as the type they return. And yeah, the usual way to get around that is to stick a ugly get in front of it, which I am not a fan of. But it is what it is. So where was I? In fact, I think I'm going to call this value again. No, I can. Okay, so what we're saying here is that in this specific case, since the type is a call stack index, its value is indeed a call stack index. I did code this Vectrex emulator live. I did start it before I started streaming, so I didn't start like with an empty main. I did start writing it initially on my own, and then very early on started streaming it. Yeah, it's all on YouTube. It's many hours of me scratching my head. I like the joke that if you take any random frame of all my streams, the majority of the frames is me going something like this. I'm always thinking and touching my face. I just noticed that when I would go through my streams, a lot of time there's these, it picks a random frame for the thumbnail, and I noticed all my thumbnails kind of look the same. Yes, exactly. Oh, well, thank you, Demi Plume. I'm supposing you're referring to my explanation of L value and R value references and move and all that? Or do you mean just in general? Oh, okay. Cool, cool. Well, thanks for that. I appreciate it. I actually wasn't sure if it was clear. One of those things where it almost felt a bit like an interview question, right? Tell me what is move in C++? Wondering if I could actually do this here. Int call stack index without casting it, and then would it be okay for me to index with it? Probably would complain about the indexing. C++ is love. I don't know. I mean, I really like C++. I've been using it for a long time. I do wonder if it's a bit like I like it a lot because I had to use it, because I learned it so that I could make games. And I know the language very well, but my relationship with C++ is that I like a certain subset of it, but I think it's a very complicated language. And I think it's getting really, really hard for new people to learn it. And what do I think about Rust? So I know a little bit of Rust. I started reading the Rust book and started doing examples. I love the idea of Rust. I'm still not enamored by all the syntax, like the lifetime syntax and all that, but I can't say I've spent enough time to form a solid opinion. But I love the idea of it. I like the idea that everything is immutable by default. Everything moves by default. Speaking of move, and that there's this borrow checker that can basically guarantee that you don't do anything, nasty in terms of shared ownership. So that's pretty awesome. So yeah, I need to do some more Rust, surely, to form a stronger opinion on what it's like to write Rust. I don't have an opinion on that. In terms of C++, I've been doing it for a really long time, like it's over 20 years. And I'm very comfortable and obviously with it. I'm very familiar with it. I read compiler errors and know what they mean. But I know that for someone new to this language, especially today, it's very tough. Yeah, cargo is super cool. We definitely need something like that in C++. Okay, so did this build? It did build. Let me see if it actually works. Still works. So Demi Plume, you say you wanted to try and learn Vulkan. There's a lot of documentation, but it's C++. That's true. That is true. I don't know what to tell you to help you on there, because it's true that a lot of Vulkan is, I mean, it's actually more C than C++, although most people use C++ to teach it. The actual spec and the SDK, it's all in C, right? But yeah, if you're not familiar with C or C++, it can be a bit of a daunting task, I'm sure, to learn. Yeah, Vulkan is definitely more complicated. Actually, I work on something related to Vulkan. My day job is I'm part of this really cool team that writes a Vulkan implementation, like a driver for Vulkan that targets the CPU, like a software renderer. And yeah, it's a really cool project. So I've actually been learning a lot of Vulkan. I didn't know that much about it before I joined the team. I knew what it was, and but I hadn't used it. I definitely know more OpenGL, but yeah, Vulkan's very interesting. Very low level. I would say it's not super useful for small games and applications and stuff. Like for my emulator, it would be kind of overkill. I am thinking at some point of writing a Vulkan backend for my emulator just so that I learn it, but not because it would be useful. But for high performance 3D stuff, it's definitely better than OpenGL. Yeah, so basically it's called Swift Shader. Swift Shader, if you want to look it up. I guess I can show you. So this is the project. It's also on GitHub. And it's a high-performance CPU-based implementation of the Vulkan and OpenGL ES graphics APIs. I don't know what this 12 is here. Its goal is to provide hardware independence for advanced 3D graphics. So it actually performs quite well, and it's used in a whole bunch of different applications, but one that a lot of people would know, and it's because it's open source, is Chromium. So Chrome, the browser, it uses it under certain conditions. So it uses it when it cannot use or chooses not to use your GPU. So for example, if you run your browser on a system that doesn't have a GPU but has a screen, so think I don't know, embedded devices or really crappy phones that run Android that don't really have a GPU or have a really bad GPU. This thing can be useful. Or let's say you're running it on a powerful desktop that has a graphics driver that keeps crashing because it's a buggy driver. After crashing, I think 3 times, Chrome will switch to Swift Shader. So at least you get your pages rendered. And for the most part, rendering content in a browser, even if it takes a little bit longer, most people don't seem to care. It's not like you're using it for high performance games. You know what I mean? Yeah, it's a cool project. Really, really fun. Okay, so this works. It works. I very much am hating this code. I really need to take this out. So I'm going to be factoring this out soon enough. I have to actually, in order to display the different types of variables. All of this has to be yanked out, I think. Yeah, all of this here. Yeah, lots of optimizations. The biggest thing, what makes it fast, is that it does JIT, so just-in-time compilation, all over the place, and it makes heavy use of SIMD to parallelize a lot of the operations that, just like the GPU effectively parallelizes lots of operations. We try to take advantage of the CPU's parallelization of instruction execution with SIMD. So that definitely makes it fast. And the fact that it's JITted means that it can be compiled to take advantage of, well, I was going to say take advantage of the target architecture, but also mainly to sort of like get rid of branches. So the idea is to think of like, think of like a function that has, if you think of OpenGL, right? OpenGL supports something like, I don't know, let's say 30 different texture formats. So if you think about the code that you'd have to write in a software renderer that deals with that, you'd have some kind of switch case that handles every single texture format, right? Now, if that's what you're doing at runtime, it means that every single time you run that function, it's got to do this massive switch over a type, and it's got to go through a jump table and figure out which type it is. But the thing is, when you think about it, most applications only use maybe 2, 3 of those formats, right? So it's kind of like a waste of time. There's a lot of overhead having to check which format it is every single time when you're only using a handful. So what we do is we pick that, let's say, texture format as a key, and we generate that function that we would normally run, but this time with only that for that texture format. And then we basically map that format to this generated function. So then at runtime, when we say, oh, we want to sample this texture and do some blending or whatever, we know it's this one format, so we grab the function or functions for that format and then run them. And these are the fastest the function can be because it was dynamically compiled for that type specific format. Did that make some sense? That's sort of the idea behind using JIT to optimize. And I just gave one example, but there's a whole load of, like, there's a whole bunch of axes like that, so, and yeah, that's where a lot of the performance gains come in. You can also imagine that, like, initially, because it's got to compile these functions initially at the beginning, right, the first time, it can be like a bit slow to start as it starts to cache all these functions, compile and cache. And then once they're all compiled and you're going, and then it goes fast. And that's pretty true of any JIT-based system, right? C#, Java, those runtimes that do a lot of JIT, Python's environment, these things do JIT, and the first time it's got to actually do the JIT and store those. So over time, it gets faster and faster and faster. Exactly right. It's less CPU intensive after the load. Yeah, that's true. It is good for battery in the long run, yeah. That's also an important part. One thing we don't do, but it's something we do mention once in a while, is effectively caching, like saving to disk, let's say, saving to memory those JITted functions, so that you can reload them the next time rather than recompile them. So that would speed up the load time as well. That's cool too, but it has its own set of problems to be solved. Okay, so I'm going to try the thing I said I would do here, which is something along the lines of, I'm going to start off with a variable here and then eventually make it a data member. But I'm thinking of an ordered map. And what I need is a way to identify, so I've got the frame address here. I need a map? I don't really need a map. No, it's not the map that I do need a map, but it's not for that. Do I need a map? I actually don't think I need one. Now, what do I need to store here? Okay, so something like this, where the idea then is we go here, we get our frame address, frame, okay, so frame.address. So if the frame, clear the last frame variable cache if the function is changed. So this is that idea that I'm going to keep these variables around in this vector. I hope this is a good idea. Anyways, we'll see. No idea if this is good. So coming back to this, the idea would be that we know we want to create here so I guess the type is that of the indirect type, actually. Yep. I guess the name would be dereferencing the... Hey, thanks for the follow, Demi Plume. Appreciate it. So the name would, I guess I'm going to go for like the dereferencing of the value. The thing is, if it's a reference, that's not going to help us. But yeah, let's just go with that. just to see what it looks like. Maybe I'll just do value or something like that. We'll see. But let's say we take our, what do we have here? Right, so the indirect type, no, that's not the right one, right? That's like int star. I need the name of my variable. Here it is. So it'd be something like this. This doesn't really work for references. Although at the same time, references are shown as pointers, so maybe it's okay. Let's just go with that. And then the other thing I need to do is I've got my name, I've got my type, and of course I've got my location. And this is where all of that work came in. Because here, our location is going to be a variable ref, no, a variable absolute address of, and I gotta actually, I have it here, right? Value address. So that's the one. So that's cool. And now I gotta grab that thing that I created above, which what did I call it? I called it the variables request data dot variables, and I want to push it back. And see here, I have to move it. Oh, sorry, just saw your message there, CD compilador. I'm going to sleep. I'll see your YouTube vids to understand what you're doing. Bye. Hey man, thanks for hanging out. It's nice talking to you. Okay, so this is creating, so create a child variable to display the dereferenced value. Now, I'm going to need to add this to my DAP var. So what I'm going to do for now, I've got these here. The ID that I'm going to have to add, which is a variable ref, it's going to look something like this, but instead of a call stack index, it's going to be a child variable. And I'm going to need to give it a unique identifier here. So I'm going to need something that increments on its own. Oh, no, do I? Can I just, I can use the, yeah, I'm just going to use the index of this, of course. Because that's exactly what we store. It's going to be the index that we just pushed back. So it is this dot size -1. Yeah, -1. And of course, it's going to want me to pass that as an integer. Now this has to be added to this DAP var here. So yeah, let's move this. I have two options here. I can either move it in or Okay. And then here, we say dapvar dot variable index is equal to variable's reference is equal to variable's reference. So now, if this works, like this is not done yet, but what this should be doing is, I think actually we should be able to see the little plus appear next to the pointers with this change. And then it would only send a thing if we actually expand. Oh, okay, it's still running in here. So let's start with that and see what that looks like. There you go. So not the plus, but basically this little thing here. Now, of course, if I expand it, it's not going to work because I haven't handled it. But ostensibly, if I attach myself here, Vectrex. If I try to expand, I should get nothing. Oh, there we go. So I just got a hit. So see, my type is 2. So 2 is child variable. So that's the one that we need to handle now. In fact, if we look at, because now we're not going to handle it, but let me see here. Oh yeah, I wanted to look at this guy. Debugger won't let me, probably because I'm in a... Oh, right. Let me go to another thread. Let's go back to the main. No, that's not going to help much. That's a shame. Okay, you know what we'll do is we'll make it global for now. I like to iterate this way. You know, you're probably wondering, why am I not just making it a data member of my class? It's just that if I have to go and touch the header every time I gotta iterate on things like this, it just makes compilation longer. Touching headers means it has to build all the CPPs that include that header, and I know that I only have one instance of this class, and I know that so I don't need multiple, and if I put it in the CPP for now as I iterate on this, it only ever compiles that one CPP, so my iteration time is faster. And then eventually, I'll move into the header, and since I named it correctly, it's just moving it there, and then I'll pay the price of compiling that header that one time at the very end. Okay, so let me attach myself here. Whoops. Okay, so that hits my breakpoint here. So my variable ref is of type 1 with value 1. So it's a call stack index. So this is the one we normally hit. There's my indirect type. Let's just step through here and see what happens. So the name will be star p. It's got the same type. Location is, so this is the computed address. Looks good. And then we're going to push it back on this guy. So this is the global variable that I wasn't seeing before. So already we can see there star p, p2 and all that. I think one thing that sucks is that I'm going to be, yeah, maybe I will want to make it some kind of a map. because now I'm just constantly adding to it, and that means that it'll just keep growing and growing and growing. Yeah, that's probably not great. Okay, so I'll probably have to fix that. But it doesn't mean it won't work. It just means that it's not efficient. Okay, so let's say we continue with this. I mean, I think we see that it's working here, because if I go and I expand now, so here is where we get our variable ref of type 2 at index 5. So right now what it would like to show is this guy here. And that's star p, which makes sense because that's what I expanded. And it's got type integer, and it's got the actual location here set to be a specific offset. Very good. So right now it's not going to do anything because I'm not handling it, as you can see. Super close. All I got to do is handle it. So to do that, I gotta rip out this code here. So let's do that. What's this complaint here? It's uninitialized. Oh, right. That's true. What was I? That is true. Yeah, that's interesting. Actually, can you do this? Guess not, right? Data member initializer not allowed. All right. Not necessary, but that should shut up the warning. Okay, so let's make a function here that takes this. So what are we doing here? Take a variable. Yeah. So this is simple because we're just trying to set a display value, but and display type is simple enough. It's this else branch here. We're going to set a display value display type, but we have to do this variable reference thing. Just less elegant, that's for sure. So maybe instead of doing it here, I can do it on the outside. Not quite. So maybe what my function should do is take a variable and return a DAP variable. That's effectively what we're trying to do here. One problem though is I need to have access to this data member here. Yeah, that's relatively gross. Unless I get back the oh yeah, now I even create a variable here. Oh, what a mess. Really not a fan of this. The fact that I'm struggling with this design makes me feel like this isn't probably the right solution. But okay, let's just see where it takes me. So it's something like I don't even know what to call it. Let's create that variable. Let's go with that. And we give it a variable. For now, I'll pass this in. Hey, what's up, Lord Alpaca? Where did you learn C++, man? I mean, I learned it from books and yeah, books, I guess. I started learning C++ around 97, 98. And I started with Pascal, then I moved to C. And then after that, I started learning C++. I actually took a course in C++ just before university. And then I went into computer science, and we actually did computer science. We actually did C++ in my computer science, like for my degree back in the day. And but I mean, yeah, you're saying this is rather modern. This is just me, you know, sort of keeping up with C++, like buying books and watching videos and reading and trying to learn more and more. And of course, you know, practicing it, right? Like my day job has me programming in C++, so you know, learn a lot from work. But it's true that, like I said this earlier, at work I've always been limited to an earlier version of C++. So like right now it's 14. That's pretty recent. It was 11. So all the more modern stuff. This is sort of why I work on these personal projects, is that I get to use the more modern stuff and actually practice it. Okay, so let me grab, I think it's all this, right? Or did I go too far? I think I went too far. Yeah, that looks about right. Oh yeah, I'm gonna need to pass in a variable address, I think. Let me see. Yeah. And of course, that's only in the case where it's this type, right? Oh, no, I need it here as well. Yeah, that's true. So here's my variable. This is my variable address. So yeah, let's do this. Let's grab this again. Herbsider says that the reference operator is pretty expensive. So you're saying that in relation to what? Did I say something about that earlier? Memcopy is kind of unsafe. So memcopy is only unsafe if you use it, you know, there's undefined behavior for memcopy if you basically try to copy from a buffer that's overlapping, right? So if your source buffer and destination buffer overlap in terms of the size, then yes, right? That's undefined behavior. But apart from that, it's quite safe to use. I mean, you do need to be careful with it, for sure. I should probably just make this a member function now that I'm looking at it. Okay, so in preparation to make it a member function, I'm going to call this m_ here. This is not correct, but whatever. And same thing for my memory bus. I think my memory bus is a pointer. Yeah. Yeah, I mean, if you're trying to copy a type, you know, if you're trying to copy from an array to an array or something, it's a byte copier, right? Memcopy copies bytes. So as long as you know what you're doing, but yeah, you got to be really careful. There's no doubt about it. But as it turns out, you know, reinterpret cast, which is what I'm avoiding here. I would have normally used reinterpret cast, but I used memcopy. If you use reinterpret cast, that's actually, there's more undefined behavior around reinterpret cast, and the solution is to use memcopy. So yeah, I mean, those things, memcopy and reinterpret cast, those are tricky bits of business in C++, and I'm probably, you know, invoking all kinds of undefined behavior in my code, which, you know, I try not to, but sometimes it is just the easiest thing to do, especially when you're dealing with bits and bytes and, you know, trying to abstract types away and bring them back in an efficient manner, like type erase effectively. Okay, so this is good. This means I can return dapvar here, if I did this right. And then this looks something like so let's see this builds. Gotta stop this. Yeah, that's true. I do like std copy, and I use it when it makes sense to use it. I literally only use memcopy for the case of working around what reinterpretcast would do. So if you're talking about my memcopies here, if you look at what I'm doing here, this is already like, you know, I'm dealing with taking an integer and breaking it up into 8 bits and 24 bits. And what I'd like to do is have a way of returning one integer that has these two values. So there are different ways for me to do this. One way is to do what I'm doing here, is to memcopy myself into there, knowing that I am exactly equal to a size of an integer, and vice versa here, taking in a value and storing it there, so spreading it out. But an alternative would have been, and I started doing that, is to like wrap this up in a struct and have a union that unions an int with these, and then I could just use whatever the compiler decides to lay it out, and I would get rid of the memcopy. But this effectively, when you look at how the compiler generates the code, it doesn't actually perform a memcopy. This gets optimized out. So this just ends up copying the values directly, and same thing here, it just ends up returning the values as an integer. There's no actual copy in this case. So okay, so it doesn't like this, fine. We'll get back to that later. You're not familiar with this syntax, the breaking up of ints into like bit fields, they're called. Yeah, it's pretty esoteric. It's not something you should see or use often. I'm using it here because I'd like to store. You know, I could have done this differently. Instead of using this, I could have just done some bit shifting. That would have worked as well. You know, decide that I'm gonna take your type value and as an integer and shift it to the left 24 bits, 24 by 24, and take the value and take the existing value and like or it in. But that's exactly what the compiler does for me. If I use bit fields like this and you look at the generated code, it's just going to emit shifts and mask, oring into the value for me. So it's pretty neat. So since it's exactly for that, I may as well take advantage of it, right? The only time this will fail me is if I require the bit fields to be in a certain order. Let's say if I have to share this value between different machines, but that's not my case here. So because the ordering of where the bits end up is not specified. Okay, so this builds. Now for the part that we've all been waiting for. So we come back here and we say, if the type is that, else, if it's not call stack index, but it's an absolute, a child variable that we're dealing with, then our variable ref's value is in fact an index. I think I have to do this. I guess I can do size t, yeah. So I get this value, and now I go and grab variables of index. I get this variable here. And I guess I just do a pushback. And I gotta call this function. Oh, thank you, I guess. Right, and then the variable address is actually this variable's address, right? That's what I need here. Actually, what is this variable's address? Right. Right, yes, okay. In my case, okay, I'm gonna have to do this. So we know that's not a stack offset. In this case, it's gonna be an absolute address. That's it. So we don't do that. We just say, yeah, there we go. To get like that. Child variables always contain an absolute address. Pointers, references. So we grab that var address, we do this, and then we add it back. So I think this is what we need. Let's see. Would be fun if it works. Holy crap, that actually worked. Holy moly. So these are all garbage values because these addresses are not right. But as they become right, holy moly, it's actually working. Oh, cannot believe this. I did not expect this to work. At least not the first time. Now this will be interesting. See, it's a pointer to a pointer. So now, holy crap, it actually fucking works. Man, look at that. This is so cool. Okay, I'm like super happy right now because I did not expect this to work the first time. I wrote so much code and refactored and I was sure this was going to crash and go bad, and it's actually doing the thing. It is a debugger for C++. Basically what it is, okay, so this looks like a C++ program, right? It is. It is being compiled with a compiler that is a fork of GCC. I think it's 4.6. But this fork is a fork that targets the 6809 CPU, which is the CPU for the Vectrex. So the idea here is, now I didn't do that part, like somebody took somebody did the part of modifying this GCC fork, then somebody else took it and like wrote a couple of make files and stuff so that you could make games for the Vectrex with it. Now I took that and I added some stuff to the linker scripts and stuff so that we can actually make C++ programs, because up to that point, and I think no one has ever made a C++ program for the Vectrex, but I'm making C++ stuff. Now that's cool, but I'd like to be able to debug it. And unfortunately, despite it using GCC, it does not generate ELF with dwarf. It doesn't generate any of that. The dwarf being like the debug symbol format that GCC creates, and Clang and all that. So basically what it does though is if you pass -G for create debug info, it generates these like listing files that contain this data. This is exactly what it is, what you see right here. Let me close this. So when you compile with -G, it creates a listing file, and this listing file has this information called the stabs information. It stands for like symbol table strings, I think it is, or something like that. And this is the debug info. It's a textual format, and it describes, like, let's just say stab. There's a whole bunch of information in there, and this describes like the matching of, let's say, this is the assembly instructions, and this tells you what line number it goes with. These two go with line number 105 in the source file, which is over here, And so what I'm doing is my Vectrex emulator is parsing these files, collecting all of this data, storing it as debug information, and then it's implementing this debug adapter protocol, which VS Code speaks and a few other editors speak, so that it's kind of like a generic debugging thing. And so code then connects to my emulator, and it starts speaking with it in this protocol. And then I say, okay, yeah, I speak this protocol, and then it says, okay, well, give me information like, what source file are we in? It sends me like commands like step into, step over, and then it asks for stuff like, show me the variables for the current location. And so I have to basically provide all that, and that's basically what I've been working on. So it's implementing, say, the backend for the server for this debug adapter protocol, so that we could compile and debug C++ or C, C++ programs for the Vectrex. And yes, I do own a Vectrex since I was a kid. My uncle bought me one, and I had it in my closet for many years. I'd pull it out once in a while, play with it, put it away, and I have it here. It's in my garage, and it's cool. It's a really cool system. So I thought, after I wrote an emulator for the Nes, I thought, why not write one for the other system I own that I loved? And that's how this project got started. So yeah, so this project's pretty cool, like writing a debugger. So I'm getting to realize just how much work. It's really a lot of work to write a debugger. One thing is, of course, like the stab format is not amazing, so I do spend a lot of time just kind of like figuring out how to get what I need from this info. But it's good enough. Like one thing you can see here is these are references, but I have no idea that they're references, so I have to show them as pointers. It's like if you look here, R3, it says it's an int star. Technically, it's not an int star; it's an int ref. But I can't know that. There's just no way. Because if you look here in the stabs information where it describes all the variables, it'll say R3 is a pointer of type 7. And what is 7? If we come up here, 7 is an integer. So as far as this compiler is concerned, and it makes sense, compilers don't really distinguish references from pointers, that's okay. But it would be nice if the debug info actually told me this is actually a reference, then I could actually put a ref. But I cannot. So unless I do my own parsing, which I won't do, I don't think that's worth it, but there's just no way for me to know. I'd have to like literally parse the source and try to find, you know, declarations and stuff. Yeah, you could totally, if you want to use my NES emulator, let's just go to my GitHub. So that's my GitHub. You'll see here, there it is, Nes Emu. I think I have releases for it. Yeah. So I think that's, did I actually provide binaries for it? I don't even remember. This is just the source code, isn't it? I haven't looked at this project in a while, so I don't remember. I thought I had a way. I thought I had a place to download it, but maybe not. So one cool feature of this emulator is actually you see it here. Rewind support. Press backspace at any time to rewind at normal speed up to 1 minute. So that's my favorite feature I added to my emulator. And I know now a lot of emulators have it, but when I did this, I had only ever seen one that did it. So, what is this? Yeah, I think, unfortunately, I don't think I have any executables for this. Z Super NES? Yeah, so yeah, rewinding as in like saving states and then, you know, jumping back. What's cute about mine, I don't think I can demo it, but what's cute is that, can I? Maybe I can. Let me take a look. Although I should really stop because it's getting late. Let me see if I can. I don't know if I still have a build here. I do. Okay, so I can show it. Let me find some ROMs here. I have no legit ROMs, so it's okay. Don't tell on me. Where the hell do I have ROMs? Just give me a second. Okay. This should do. Sorry, it's just weird. Doing some stuff off screen here. Okay, I think this should work. Whoops. Okay, here we are. Oh, this was a version where I had some debug stuff going on. I think this was a version where I was debugging audio. Let me see, do I have a version that doesn't have that crap? Maybe. This one? Okay, this one looks all right. But there's no sound. I think this is like an old version where I definitely had sound working. Unfortunately, it doesn't seem to pause. Oh yeah, I had some pause and stuff. Okay, so how do I play this again? What are my keys? Oh, there you go, music. That's true, the Super Mario has no music at the beginning. Now if I hit backspace, whoops. So that I'm just holding backspace here. There you go. That's my little demo. So yeah, this was my first emulator, and Vectrex is my second. Thanks, man. Appreciate it. Excuse me. I think I need to stop talking because I'm all talked out now. Anyway, this is freaking cool. I think it would just be fun to do one more little thing here. Oh, thanks, Lord Alpaca. I don't know what it takes to get more followers. I guess I'm not cool enough. So let's for fun do a triple pointer because those are awesome. And then let's do a reference to a triple pointer. Does that even work? Oh, I think it's the other way around. Reference here. Let's have some fun with this. So here I'm gonna, no, don't like it? Oh yeah, gotta still do a dereference 3 times. So one thing about this compiler is it's GCC 4.6, so it's really old and does not support C++ 11, very sadly. So I'm forced to code in C++ 03 when I write my Vectrex games. Okay, I just want to see here. So P like that. Like that. So there you go. That's triple level. And then this one should be 4. So let's go through here. Okay, I'll expand them all. How do I... Can I close this? There we go. Like that. And there you go. So the Vectrex came out in 1983, and that coincided with the video game crash in North America and Europe. And so unfortunately the Vectrex came out at like the worst possible time and got completely destroyed. So the company had to shut it down, sell what they had at bargain prices, which is pretty much how I got mine. I was a kid, but my uncle, at the time was, he about 10 years older or something, and he basically was at the store and he saw that they were discounting these Vectrex machines for like crazy prices. So he picked up 2 and gave me one. I think I was like 7 or 8, and he bought a bunch of games. So it was not very popular, but you'd be shocked. There's quite a following for it, like lots of people want one. Those who have it, there's actually like groups, I'm part of a group of Vectrex fans, and what's really impressive is there's quite a lot of homebrew that's still being done to this day, which is sort of the impetus for my work here, because I know a bunch of people are writing homebrew. They're using a similar tool chain, and then they are using this compiler, and there aren't really great debugging facilities. There is this one very cool environment that allows you to do a lot of stuff for the Vectrex, and it has its own sort of like homemade. It's a C debugger. It's not C++, but I haven't actually used it. I should try it. I think it's all right, but it won't. I don't think it can achieve the same level of debugging that I'll be able to achieve with this, just because this is a full-fledged debugger, you know. So, but maybe I'm wrong. I shouldn't judge it until I've tried it. But I think that's the only other option out there. So yeah, maybe on stream at some point I'll grab the other one and take a look at it. Oh, it does use vector graphics. Oh, okay, you haven't actually seen it in action, right? I should show it to you. So let me demo the actual emulator, and then I'll go to bed. Okay, you're watching a video. So like if I just block this out. Yeah, that would be really cool. There are quite a lot of spaceship-like games, but definitely not Star Fox. It's not a super powerful machine in terms of like what you can do, but so like this is Mindstorm here. So this is sort of like the Asteroids game. It comes built in, so you can fly your ship around. You can fire. And if you shoot mines, they explode, and then so yeah, basically like that. There's a lot of cool games. There's like so okay. Anyway. Let's see. This pinball game. So yeah, cool stuff like that. All right, so guys, I think this is where I need to sign off because it's past midnight for me, and I'm, you know, this works, so I'm super happy about it. I do need to clean up this code and all that, but this is the basic idea. This is what I wanted to get at. I'm not sure that this is the right approach still. I'm not a huge fan of what I'm doing, and I need to clean this up. I'll think a little bit about it, but I think it's in the right direction. So clearly, because it's doing something. But yeah, I gotta think a little bit more about ownership of these things and creating variables on the fly. But still, very, very happy that it works. So thanks for watching, and I should be back next week on Tuesday, as usual. Tuesdays and Thursdays. So take care.